Ever wondered if air has weight? Today, we will prove it does. You see, air might seem light and invisible, but it exerts a force we call air pressure. This unseen force is powerful, and it's all around us, pushing against everything in its path. But how can we prove something we can't see? Well, we can do it with a simple experiment, using everyday items you can find around your house. All you'll need is a glass of water, a piece of cardboard, and a bucket. Make sure your bucket is large enough to catch any potential spills, because we're about to challenge gravity. First, fill your glass all the way to the top with water. Then, take your piece of cardboard and place it on top of the glass. Now, here's the fun part. Hold the cardboard in place and carefully flip the glass upside down. Make sure your bucket is ready underneath, just in case. Now take a deep breath and let go of the cardboard. What happens? The water stays in the glass. But why didn't it spill? You'd think that gravity would pull the water down, right? Well, this is where the magic of air pressure comes in. You see, air pressure isn't just a force that pushes down on us from above. It also pushes from below and from all sides. When you turn the glass upside down, the air pressure from below the cardboard is greater than the pressure inside the glass, and this difference in pressure holds the cardboard in place. In other words, the weight of the air is stronger than the weight of the water. Isn't that fascinating? We've just demonstrated that air, even though we can't see it, has weight and exerts pressure. And it's this pressure that's keeping the water from spilling out of the glass. Did you see that? The water didn't spill. This is because air pressure is holding the cardboard in place. Pretty cool, huh? Ready for some dancing raisins? Let's get into it. Now, what do you think will happen if we drop some raisins into a glass filled with soda water? It sounds like a peculiar question, but it's the basis for our next experiment. This experiment combines the fun of dancing with the principles of buoyancy and density. First, let's gather the materials needed. We'll require a clear glass, soda water, and a handful of raisins. The glass allows us to observe the magic in action, while the soda water and raisins are the main performers in this dance. Our experiment is simple. Fill your glass with soda water. Now drop a few raisins into the glass. What do you observe? The raisins start to dance, don't they? They rise and fall, bobbing up and down in a rhythmic motion. But why is this happening? This dancing is all about buoyancy and density. The raisins at first sink to the bottom because they are denser than the soda water. However, the soda water is carbonated, filled with tiny bubbles of carbon dioxide gas. These bubbles attach themselves to the rough surface of the raisins, causing the raisins to become less dense. This change in density makes the raisins float to the surface. But the dance is not over yet. Once the raisins reach the surface, the bubbles pop and the raisins become denser than the soda water again. And so, they sink back down. This cycle continues, giving the illusion that the raisins are dancing in the soda water. This experiment is a fun way to understand the concepts of buoyancy and density. It shows that even simple, everyday items can be used to demonstrate complex scientific principles. So, the next time you have a glass of soda water and some raisins, why not try this experiment and watch the raisins dance? And there you have it, dancing raisins. The bubbles in the soda water lift the raisins up, and when the bubbles pop, the raisins sink back down. Who's up for some hair-raising fun with static electricity? Ah, static electricity, the invisible force that gives us those shocking surprises when we least expect it. But what exactly is it? Simply put, static electricity is the result of an imbalance between negative and positive charges in an object. These charges can build up on the surface of an object until they find a way to be released or discharged. For today's experiment, we'll need two very basic materials that you can easily find at home: a balloon and small pieces of paper. Any balloon will do, and the pieces of paper should be lightweight, like confetti. Now, let's dive into the procedure. To start, you'll need to inflate your balloon. Once it's inflated, tie it off to make sure it stays full of air. Now comes the fun part. Rub the balloon on your hair. Yes, you heard right. Rub it back and forth a few times. If you're wondering why, it's because when you rub the balloon on your hair, you're creating static electricity. Here's what happens. Your hair is giving off electrons to the balloon. These are tiny particles that carry a negative charge. Now, the balloon has more electrons and a stronger negative charge, while your hair has fewer electrons and a positive charge. All right, now take the balloon and bring it close to the pieces of paper. Don't touch the paper, just bring the balloon near it. And voila! You'll see the paper sticking to the balloon. But why does this happen? Well, the negatively charged balloon attracts the neutral pieces of paper. The paper isn't charged, but it's influenced by the balloon's strong negative charge. The balloon's electrons push the electrons in the paper away, leaving a positive charge that's attracted to the negative charge of the balloon. Isn't that amazing? With just a balloon and some paper, you can visibly see a physical phenomenon that's happening all around us all the time. Did you see the paper stick to the balloon? That's static electricity in action. Ever seen colors dance on milk? Let's make that happen. In the world of science, there are principles that govern how substances interact with each other, and one of these is the concept of surface tension. You may have noticed that some insects can walk on water, or that a carefully placed needle can float. This is all thanks to surface tension, a force that holds the surface molecules of a liquid together, creating a sort of skin on its surface. Now let's bring this concept to life with a fun at-home experiment. Our necessary tools for this scientific adventure are pretty simple: a plate, some milk, food coloring of your choice, and a little bit of dish soap. The first step is to pour just enough milk onto the plate to cover the bottom. The milk serves as our canvas, where the magic of surface tension will be displayed. Think of it as the stage where our colorful dancers will perform. Next, we add the stars of our show, the food coloring. Drip a few drops of different colors into the milk. You can choose any colors you like and place them anywhere you want on the milk surface. The food coloring will remain mostly stationary due to the surface tension of the milk holding it in place. Now, for the grand finale. Dip a cotton swab or the end of a spoon in dish soap, then gently touch the milk surface with it. The moment the dish soap comes into contact with the milk, something amazing happens. The colors begin to move, swirl, and mix, creating a beautiful dynamic display. Why does this happen? Well, the dish soap is designed to break down fats and oils, which are what the milk's surface tension is made of. When we add the soap, it breaks the surface tension of the milk, causing the colors to break free from their stationary state and swirl around the plate. Wow, look at those colors go. The dish soap breaks the surface tension of the milk, causing the colors to swirl and mix. This experiment not only creates a beautiful spectacle, but also provides a fascinating glimpse into the science of surface tension. Well, that was a blast, wasn't it? We have just journeyed through the intriguing world of science, right from the comfort of our homes. We've explored the power of air pressure, the buoyancy of dancing raisins, the magic of static electricity, and the beauty of colorful milk swirls. Each of these experiments has given us a glimpse into the remarkable principles that govern our everyday lives. Let's take a moment to recap. We started with the power of air pressure. It's the invisible force that surrounds us, and it's responsible for things like weather patterns, flight, and even helps you drink from a straw. Incredible, isn't it? Then, we moved on to dancing raisins. This fun experiment showed us buoyancy in action. Remember how the raisins started to dance when they were dropped into a glass of soda? That's because the bubbles of carbon dioxide gas stuck to them, making them less dense than the soda, and they floated to the top. Once the bubbles popped, the raisins sank again. This cycle continued, and we had dancing raisins. Next was the magic of static electricity. Remember how we made a balloon stick to a wall or attracted small pieces of paper? That's static electricity at work, caused by the transfer of electrons. It's the same principle that gives you a shock when you touch a doorknob after walking on a carpet. Our last stop was the colorful milk swirls. It was a feast for the eyes, wasn't it? But it wasn't just art, it was science. This experiment showcased the principle of surface tension. The soap we added broke the surface tension of the milk, causing the food coloring to swirl and create beautiful patterns. These experiments are more than just fun. They offer a hands-on way to understand the scientific principles at work all around us. But remember, the journey of discovery doesn't end here. Science is fascinating, and the best part is you can explore it right at home. Remember, keep questioning, keep exploring, and most importantly, keep having fun with science.